This video is on Unit 11, Lessons 9 and 10, and Lesson 9 is all on applications of what we've learned in the previous lessons. So it's basically word problems with trig. So exercise 1 talks about tides. The tides in a particular bay can be modeled with an equation using a cosine curve. T represents the number of hours since high tide, and D represents the depth of the water in the bay. The maximum depth is 36, the minimum depth is 22, and high tide hits every 12 hours. So that's key. 12 hours tells us how many hours have to go by for us to see one complete cosine curve, which, if you recall, when you see one complete curve, that is your period, how long it takes to see one complete curve. So the maximum depth is 36. So cosine curves, remember, they start high, go low, and end high. They look kind of like a ton, if you stuck out your tongue. So the highest point is 36. So this will be 0, 36. The lowest point is 22. And we're going to see one complete curve every 12 hours. So that means I'm going to end up here at 12, 36, because 12 hours will have gone by, which means my lowest point is going to be down here at 6, 22. So it's going to look something like this. And if I do it within one day, so 24 hours, I'm going to see one more complete cycle. So I will end at 24 hours with a max depth of 36, and halfway between 12 and 24 is 18, so that would be 1822. So that was it for part A. They just wanted us to sketch the scenario of what was happening, and I did within 24 hours for 2 full periods. So part B is to basically determine the equation of this graph, which means you need to find the amplitude, the frequency, and if there was a vertical shift. Well, there definitely was a vertical shift because it is the midline is not the x-axis. The middle of that graph is not down at 0. So the first thing I like to find, which, I mean, you can do these in any order really, I like to find the amplitude, and to do that I find the distance from the highest point to the lowest point. So 36 minus 22. And then, so I'm trying to find the amplitude, so that's 14. Well, the amplitude is half of that. So amplitude would equal 14 divided by 2, which is 7. So that means my height from the midline to the top of the curve or the bottom is 7. So I can now find my midline, what number this line is that goes halfway through the curve, by either subtracting 7 or adding 7 to 22. So that's going to be 29. So that tells me actually my vertical shift. My C is at 29. I went up to 29 because that's halfway through the highest and the lowest points. The last letter I need in order to write my equation is B, which is the frequency. Well, if we know the period, we can figure out the frequency, because remember, period is always 2 pi over b, which is the frequency. Well, I know the period. The period tells you is how long until you see one complete curve. Well, we know it's going to be 12 hours. So I know that the period equals 12. So now I can plug in 12 for P and now solve for B, since it's the only variable missing at this point. So if I multiply the B over to the other side and then divide the 12 over, I get 2 pi over 12, which is pi over 6. So now I can write the equation of my curve. It is y equals, my amplitude was 7. It's a cosine curve. My frequency was pi over 6. They wanted us to use t. And then my vertical shift was 29, plus 29. I went up 29. So that is it for part B. Now part C says, tanker boats cannot be in the bay when the depth of the water is less than or equal to 25. So 25, if I sketched where that would be, it would be maybe right around here-ish. So I want to know at what time can I not be in the bay, and I can't be in the bay if I'm less than 25. So that would be from here to here and from here to here. So this is where you would take your calculator. You would graph the following two equations. You would graph our cosine curve, pi over 6t plus 29. You would also graph y equals 25. You're going to find where they intersect. Where they intersect, you're looking for, they want to know at what time. Time is the x value. So you're going to find these intersection points, and you're going to look at the x values. And you cannot be out on the bay when you're in between these two x values and these two x values, because that would give you a depth that's less than 25. So it turns out, once you use your calculator, that between 4.2, if you're less than or greater than or equal to 4.2 and less than or equal to 7.8, that would give you this time frame. You would be less than 25, less than or equal to. Or there's another spot where that's going to happen within 24 hours, and that intersection turns out to be between 16.2 and 19.8. So between those two time frames, you cannot be out on the bay for whatever reason here they said, safety reasons. So make sure that's primarily done on the calculator. So if you had to show your work, you would show us which two equations you typed in, said you found the intersection, and make sure you label your points on your graph to get full credit. Now, exercise 3, we are going to save to do in class. So we're going to do this one. It's very similar to what we just did, where you're going to have to find your A, B, and your C based off of the situation that's happening. So we're going to do that in class as our warm-up. So moving on to the next lesson. Lesson 10 is a kind of a review. There is some new stuff in here about tangent. So back from geometry, you had learned that tangent is opposite over adjacent. Really quick review here. The opposite side is the side that is opposite the angle you're working with, and adjacent means next to. The third side that I didn't label because tangent doesn't involve it, but that's the hypotenuse. So you are going to need to know, because you're probably going to be missing one of your sides of your right triangle. It's probably going to be one that you need. You need to know the Pythagorean Theorem, which we reviewed in class already. Remember, you can only use that with right triangles, and C is your hypotenuse. A and B are your two legs. So if you look at exercise 1, we want to know what the sine, cosine, and tangent is for this angle. So we can figure out at least one of them right away, because, and I'm going to label these with O, A, and H, so I know which one is the opposite hypotenuse and the adjacent. So 5 is the hypotenuse because it's across from the right angle. This is the opposite side because it's opposite my angle, and this leaves the adjacent. So really quickly, I always write SOHCAHTOA out like this. If you have another way to write it, that's fine, as long as you know which sides go with which trig function. So the one I can tell you right away is cosine. The cosine of that angle is the adjacent over the hypotenuse, so that's 4/5. I don't know, though, the sine yet or the tangent, because those both involve the opposite side, and I don't know what it is yet. If you recognize that if 5 is the hypotenuse and 4 is another one of the legs, that is going to be a Pythagorean triple, which means the other leg is going to be 3. You don't have to show the work to find that if you know that that's a Pythagorean triple, because math people know that that is a Pythagorean triple, so you don't have to show your work. You can if you'd like. So the opposite now is 3, so therefore the sine is 3/5 because opposite over hypotenuse, and the tangent is opposite over adjacent, so that's 3/4. Now this one, you're going to have to show a little bit of work here to find the opposite side, because 1 and 2 is not a Pythagorean triple. So it is 1 squared plus x squared equals the hypotenuse 2 squared. So that's 1 plus x squared equals 4. Subtract the 1 over x squared equals 3. X is the square root of 3, and leave it as radical 3. So now we can find the sine of that angle. Opposite is radical 3 over the hypotenuse, which is 2. The cosine of that angle is adjacent, which is 1 over the hypotenuse, which is 2. And the tangent of that angle would be opposite over adjacent, so that's radical 3 over 1, which is just radical 3. Now here's the new stuff. So none of that should have been new. That should have been a review from geometry mostly. Exercise 2. Consider this unit circle drawn. If xy represents a point on the circle, how can we define the tangent function in terms of this point? So here's the angle we're working with. It's right near the origin. So the tangent of theta, if you think back to your SOHCAHTOA, is opposite over adjacent. Well, the opposite side is whatever this y value is. So we're going to just leave it as y. The adjacent side is x. So that's the answer to part A. But now you're going to use your knowledge of which trig functions x and y represent. I've told you in previous videos that x and y are your cosine and your sine. Remember, it's alphabetical just like x and y are alphabetical. So C, S, C comes before S. So that means that tangent can be written if you know your sine and your cosine value, which you should. So the y can be written using sine, and the x can be written using cosine. You must memorize this. You must memorize that the tangent can be written as sine over cosine. The reason why this is helpful is because we have memorized the sine and cosine values of 30, 45, and 60, and then our other angles, 0, 90, 180, 270, we can use the calculator for it. But if we know sine and cosine of those angles, we can figure out the tangent by knowing that the tangent equals sine over cosine. So for example, to find the tangent of 60, now could you use your calculator? Yes, but it's not going to give you the exact answer. It'll give you an ugly decimal. So the tangent of 60 can be rewritten as the sine of 60 over the cosine of 60. Well, you know those. You should memorize those. The sine of 60, and I'm kind of running out of room here, is radical 3 over 2. The cosine of 60 is 1/2. Remember, when you have a fraction over a fraction, you have to copy, change, flip. So that's radical 3 over 2 times 2 over 1. The 2's cancel each other out, and you're left with just radical 3 over 1, which is radical 3. Now your calculator would have given you a gross decimal because it won't tell you that it's radical 3. The tangent of 45 can be written as the sine of 45 over the cosine of 45. Well, if you recall, the sine of 45 and the cosine of 45 are both radical 2 over 2. And when you have, yes, I could copy, change, flip this, but it's the same thing over itself. And when you divide something by itself, it's just 1. Now, the tangent of 150. We do not know 150's sine and cosine value. I will rewrite it as the sine of 150 over the cosine of 150. I don't have those memorized, but I do know that 150's reference angle, if I drew 150, his reference angle is 30. So therefore, I can use the sine and cosine value of 30, but I just have to be careful if they are positive or negative, because in this quadrant, something is negative. In particularly, that something is the cosine, because I'm moving to the left on the x-axis. So when I rewrite this, it's the same as the sine of 30. Sine is positive because I would go up in the second quadrant, but the cosine is going to have to be negative. So it's the negative cosine of 30. Well, the sine of 30 is 1/2. The cosine of negative cosine of 30 would be negative radical 3 over 2. If I copy, change, flip that, it's 2 over, it doesn't matter where the negative goes, So the 2's cancel out, so you're left with negative 1 over radical 3. Now normally we don't like radicals on the bottom, so we multiply it by itself to turn it into a perfect square, but whatever I do to the bottom, I do to the top. So that's negative 1 radical 3 over 3, because that would be the square root of 9, which is 3. Last one, you can use your calculator. This one is going to be nice. Whenever you're doing the tangent or the cosine or the sine of one of your angles like 90, 180, 270, it will either be 0, 1, negative 1, or undefined, because tangent can be undefined if 0 is on the bottom. So we can rewrite this as the sine of 180 over the cosine of 180. Or you can just type in tan of 180. It's going to spit out 0. If it gives you undefined, that means that 0 was on the bottom. In this case, 0 is on the top. If you don't believe me, it's actually 0 over negative 1, which is 0. 0 divided by anything is 0. If 0 ended up being on the bottom, then it would be undefined. So that is it for this video.